Namaste children, welcome to today's maths class. In the last class we discussed about areas of paths like rectangular path and circular path, and today we are going to discuss about areas of some of the quadrilaterals like a trapezium and a rhombus and general form of a quadrilateral we are going to discuss today. How to find area of a trapezium? How to find area of a trapezium? See here we have two cases are there where before that, what is a trapezium? A trapezium is a quadrilateral. It means it is having four sides. Quadrilateral means a polygon with four sides. But what is a trapezium? A trapezium in which one pair of opposite sides are parallel to each other. One pair of opposite sides are parallel to each other. Here in this trapezium, AB is parallel to CD or DC. Both these two sides, AB and DC, both are parallel to each other. Then how do we find the area of a trapezium? Two cases are there where the two non-parallel sides are not perpendicular to the parallel sides is one case that we will discuss in the next concept. If any one side of the non-parallel sides, here AD and BC, both these two are non-parallel sides, and in that two non-parallel sides, if one side is perpendicular to the parallel sides, how to find area of the trapezium? If AD is perpendicular to the side AB or the side CD, then we will call it as AD is the height or the perpendicular distance. That perpendicular distance let you represent with H. The perpendicular distance you represent with H. Now how to find area of this trapezium? Let the length of CD is A units and AB it is B units. So what is here? It is AB is equals to B units. AB is equals to B units and CD is equals to A units, whereas AD, that is the height, the altitude is H units. So here area of trapezium. In trapezium ABCD, AD is perpendicular to AB and AD is perpendicular to AB and AB is parallel to DC. AB is parallel to DC. Now we have taken AB is equals to B units and CD is equals to A units. That is AD is the altitude, that is the distance between the two parallel lines, or perpendicular length, it is how much? H units. Now we will divide this trapezium into one triangle and the rectangle. Dividing a polygon into triangles is called triangulation method, that we have come across in class 7. Triangulation method. By dividing the given polygon into triangles, we can find the area. Here we are dividing this trapezium into one rectangle and one triangle. So draw a perpendicular from point C to AB. Let it intersects at E. Now this is perpendicular. Now can we say that ABCD is a rectangle or not? ABCD is a rectangle. Why there it is a rectangle? Because AE is parallel to CD and AD, CE both are perpendiculars to the same line. Therefore these two also will be parallel to each other. That is, it is a parallelogram. In parallelogram, a rectangle is also a parallelogram. Now here CE is equals to what it is? The same distance AD. It is opposite sides are equal. Now length of AE is equals to what it is? Length of AE is equals to same AE units. AE is equals to CD. Both are equal. This length is equals to, that is A units. And let you take BE as this length as C units. BE is equals to C units. Now write it here. Here it is. EC is equals to H units. EC is equals to H units and BE is equals to C units, like this. Now AD is divided into two parts. One it is AE, the other one is BE. Length of AE is A and length of BE is C. That is, from this what we can write, B is equals to A plus C. B is equals to A plus C. Now what we have to find? Area of trapezium ABCD is equals to area of rectangle ABCD plus area of triangle BEC. What type of triangle it is BEC? It is a right angle triangle. Why? As this is 90 degrees, this also will be 90 degrees. Linear pair of angles. So triangle BEC is a right angle triangle where BE is the base and CE is the altitude. CE is the altitude for that triangle. Now area of trapezium ABCD is equals to area of trapezium ABCD is equals to what? Area of rectangle AECD plus area of triangle BEC. Area of triangle BEC. What is there here? It is in triangle BEC, angle E is equals to 90 degrees. That is, it is a right angle triangle. Now what is the formula to find area of a triangle? It is length into breadth. Length into breadth. General formula to find area of rectangle is equals to what? Length into breadth plus area of triangle is equals to half into base into height. Now you substitute here. Length is equals to what it is? AE into breadth is equals to what it is? AD, or you can take EC plus half into base of this triangle BEC is BC. So BE into height, it is the altitude is CE, like this, right? Then you substitute these values in that. Now AE is equals to what? A into AD is equals to what it is? H plus half into BE is equals to what? C into CE is equals to what? This H. A into H, AH plus half into C into H is the area of triangle BEC and area of rectangle is A into H. Now from this we have H is the common term. You take common factor H out. That is equals to H into, then what are left? It is A plus 1 into C, it is C by 2 square units. We are finding here it is area. Therefore the units will be always square units will get. You can keep that here. You get square units. Now, so take LCM inside the brackets. 2 is the LCM, 2 in the 8 is 2A plus C square units. Now 2A can be written as what? H into 2A can be written as A plus C by 2 square units. So 2A can be written as what? 2A as A plus C by 2. Now A plus C, what is B here? B is equals to what? A plus C. So sum of the length A and C is equals to B. Now replace A plus C as B. Therefore we get H into A plus B by 2. That is half into H into A plus B square units. Now area of a trapezium is equals to what it is? Therefore area of the trapezium is equals to half into H into A plus B square units. Now here what is H? H is the height of the trapezium or the altitude. What are A and B? A and B are the lengths of two parallel sides. that is area of the trapezium is equals to half into h into a plus b, that is half of the product of its altitude and the sum of its parallel sides. Half of the product of its altitude, that is h, and sum of its two parallel sides is the area of the trapezium. So area of trapezium is equal to half into h into a plus b, where h is the altitude or the perpendicular distance or the height, and a and b are the lengths of two parallel sides of the trapezium. So like this we will derive a formula to find area of a trapezium when one of the non-parallel side is perpendicular to the any one parallel side. One of the non-parallel side is perpendicular to the parallel side. Like this we will derive the formula to find area of a trapezium. Now we will derive formula to find area of a trapezium when the two non-parallel sides are not perpendicular. When they are not perpendicular, how to derive a formula to find the area of a trapezium, we will discuss. Now we will derive a formula to find area of a trapezium when the two non-parallel sides are perpendicular. Any one of the side is also not a perpendicular. Then how to find area of this trapezium? So area of a trapezium, in trapezium ABCD, AB is parallel to CD, and length of AB is A units, length of CD is B units. That is AB and CD are parallel sides. Their lengths are A units and B units. Now we will divide this trapezium into two triangles and one rectangle. So from point D, draw a perpendicular to the side AB. Let this point is E. DE is perpendicular. DE is perpendicular to AB. Similarly, from point C, draw a perpendicular to AB, which intersects AB at F. This is 90 degrees. Now we have two triangles AED and BFC. Both are right angle triangles, and one rectangle, it is CDEF. CDEF is a rectangle. So then how much is the in rectangle? Opposite sides are equal. That is length of CD is equals to length of EF. Therefore this length is equals to how much? B units. This is B units and this is also B units. Now let you take length of AE is C units, and length of BF as D units. This is D units. Now from this figure, A is equals to sum of B, C and D. Sum of B, C and D, that is length of AB is equals to length of AE plus length of EF plus length of FB or BF. Now area of trapezium ABCD is equals to area of triangle AED plus area of rectangle CDEF plus area of triangle BFC. Write those formulas and substitute. We will reach to the formula of area of trapezium ABCD. Now from the figure, write down those measurements. That is AB is equals to A units and CD is equals to B units. B units is 1, and then it is AE is equals to C units, EF is equals to B units, and BF is equals to D units, and the perpendicular distance between the two parallel sides, that is DE and CF, both are H units. That is DE is equals to CF, that is equals to H units, that is the given data from the figure. Now, area of trapezium, ABCD is equals to area of trapezium ABCD is equals to area of triangle AED plus area of rectangle CDEF plus area of triangle BFC plus area of triangle BFC. So sum of the area of triangle AED and area of rectangle CDEF on area of triangle BFC or BCF. Now what is the formula to find area of a triangle? It is half into base into height plus area of rectangle is equals to length into breadth or width plus area of triangle is equals to, again it is half into base into height. Now square units. Now you substitute those from the figure. Half into area of triangle AED. Now here base is equals to what it is? AE. Half into AE into height is equals to what it is? DE plus for rectangle CDEF. Length is equals to CD into breadth is equals to what it is? DE plus half into base for the triangle BFC, it is BF into height is equals to what it is? CF. Now you substitute all those from this equation, you get half into AE is equals to C into DE is equals to what it is? H. Half into C into H plus CD, length of the rectangle is equals to B into height, that is the width of the rectangle is equals to DE, which is H plus area of triangle, it is BFC, base is equals to BF, that is half into base BF is equals to what it is? D units into CF is equals to what it is? H units, square units. Now identify the common terms from all the three common factors from all the three things. Here we have height H and H is there. So take H common, then what is left here? It is C and 1. 1 into C it is C by 2 plus what is left here? It is B plus what is left here? It is 1 into D it is D by 2 square units. Now take LCM inside the bracket. LCM it is 2. Half into whole. 2 1s are 2. 1 into C it is C plus 2 into B 2B plus 2 into D it is D square units. Square units. Now it is H into C plus D plus 2D as B plus B you write by 2 square units. Square units, that is equals to half into C plus D plus 2B as B plus D. Now what it is? C plus B plus D. Length of C plus B plus D is equals to what it is? Length of C plus D plus D. It is 3. By adding these 3, what we get? It is the total length of AB. Total length of AB, that is A. That is H into A plus B by 2 square units. Now by taking what? 1 by 2 out, 1 by 2, that is half into H into A plus B square units. That is the half of the product of altitude and the sum of its two parallel sides will give you the area of the trapezium. In both the cases we got the same formula. Half into H into A plus B square units, where H is the altitude of the trapezium and A and B are what it is there? The lengths of two parallel sides. So in words, what we can say area of a trapezium? Half of the product of its altitude and sum of its two parallel sides is the area of trapezium ABCD. Is it clear, children? Now we will discuss an example. Find the area of the following trapezium. So you are given one trapezium in which the two parallel sides, their lengths are 7 centimeters and 9 centimeters, and the height, that is the distance between the two parallel sides, is 4 centimeters. So find its area. So let write here, let A is equals to 7 centimeters, B is equals to 9 centimeters. That is the lengths of the two parallel sides are 7 centimeters and 9 centimeters. Then height h is equals to 4 centimeters. That is the altitude or the perpendicular distance between the two parallel sides. Now area of a trapezium formula. Area of a trapezium. Area of a trapezium is equals to half into h into a plus b square units. A plus b square units. That is half into h is equals to what? 4 centimeters, right? 4 into a is equals to what? 7 plus b is equals to 9 square units. That is square centimeters or centimeter square. Simplify this. So 2 ones are 2, 2 twos are 4. That is 1 into 2, 2 into 7 plus 9 is 16 square centimeters. That is 2 into 16. 16 twos are 32. 32 square centimeters is the area of the given trapezium. So from the figure, identify the lengths of the two parallel sides as A and B and take the perpendicular distance as height. Write the formula half into h into A plus B and then substitute, simplify, you will get the answer as the area of the given trapezium is 32 square centimeters. Is it clear, children? Now we will discuss area, how to find area of a general quadrilateral. General quadrilateral. Now we will discuss area of a general quadrilateral. How to find area of a general quadrilateral? For example, you take a quadrilateral. Let this is a quadrilateral. It is a quadrilateral. ABCD is a quadrilateral. How to find its area? How to find its area? So by dividing this quadrilateral into triangles using the concept of diagonals. Using the concept of diagonal. What is the diagonal of a quadrilateral? The line segment drawn from one vertex to its opposite vertex is known as diagonal. Let you take A is one vertex and its opposite vertex is C. So by joining these two vertices with the line segment, we will get a diagonal. That is AC is the diagonal. That diagonal is dividing the quadrilateral ABCD into two triangles. Triangle ABC and triangle ADC, two triangles. Now area of triangle area of quadrilateral ABCD is equals to area of triangle ABC plus area of triangle ADC. So to find area of a triangle, any triangle, we should know the base and height. Now AC is the common side for both the triangles. Taking AC as the base, that is the diagonal of the quadrilateral ABCD, from point D draw one of its perpendicular, that is altitude, and from point B also draw one of its altitude. This is altitude and let this is H1 and this is H2. This is AC is the base for both the triangles. So the two perpendiculars from point B, let you take this as E and this as F. D, F and BE are the two altitudes drawn from the vertices B and D to the diagonal AC respectively. Now we can find area of triangle ABC and area of triangle ADC. By adding those two areas, we will get the area of quadrilateral ABCD. So what we will do here is, we will divide the given quadrilateral into two triangles by drawing one diagonal. That method is known as triangulation method. And after that, draw two perpendiculars DF and it is BE, or the two perpendiculars or the two altitudes from two different vertices. Then we can find its area of the quadrilateral. So here, area of quadrilateral ABCD, area of quadrilateral ABCD, area of quadrilateral ABCD is equals to area of triangle ABC plus area of triangle that is ADC. ABC and ADC. So ABC, what is the formula to find area of a triangle? It is half into base into height. Half into base is equals to what for this triangle? That is triangle ABC. So this is triangle ABC. ABC, and this is the E is the altitude. So here AC will act as the base and height is the BE plus area of triangle ABC. This triangle, second triangle, it is ABC. So this triangle, so ABC and DF is the perpendicular. DF is the perpendicular. Again here half into base is equals to what it is? AC into height is equals to DF. Height is equals to DF. Now we will take this, we will write it as what from this. Identify the common things. Half into half is their common and AC is also their common. Half into AC into BE in plus DF. BE plus DF. You can write here the square units. Here also square units. Then what is AC here? It is one of the diagonal of the quadrilateral ABCD. Let you take the diagonal as D. Let you take the total length of the AC as D units. So half into D into BE is equals to what? H1 and DF is equals to what is H2. That is H1 plus H2 square units. So half into D into H1 plus H2. That is half of the product of the diagonal and sum of the altitudes drawn to that diagonal from its opposite vertices is the area of quadrilateral ABCD. So area of quadrilateral is equals to general form of a quadrilateral is half into D into H1 plus H2, where D is diagonal to which the altitudes are drawn. That is H1 and H2 are the lengths of two altitudes drawn from the point vertex B and vertex D to side AC respectively. So this is the formula to find the area of a general quadrilateral. Now we will discuss one example to find area of the quadrilateral. Is it clear, children? Now we will discuss one example. Find the area of the following quadrilateral. Observe this. One diagonal is given 8 centimeters and the two altitudes are given. One altitude is 4 centimeters, the other altitude is 6 centimeters. Then use the proper formula, find the area of the given quadrilateral. So here D is equals to what? 8 centimeters. H1 is equals to 4 centimeters and H2 is equals to 6 centimeters. We are considering there. So H1 is 4 centimeters, H2 is 6 centimeters and diagonal D is equals to 8 centimeters. Now area of the quadrilateral is equals to area of the quadrilateral is equals to, what is the formula? It is half into d into whole h1 plus h2 square units, where d is the diagonal length of the diagonal, h1 and h2 are the lengths of the two perpendiculars or the two altitudes drawn to that diagonal from its two opposite vertices. Now you substitute the values. Half into d is equals to what? 8 centimeters, so write 8, and h1 is equals to 4, h2 is equals to 6, 4 plus 6 square units in the sense square centimeters. Now 2 ones are 2, 2 fours are 8, 1 into 4 it is 4, into 4 plus 6 it is 10 square centimeters. Now by multiplying 4 and 10, 4 tens are 40. So 40 square centimeters is the area of the given quadrilateral. So from the given figure, identify the length of the diagonal and the altitudes, then write this correct formula, substitute the given values and simplify, we will get the area of the given quadrilateral. So I hope you understand today's concept. What we discussed, it is two derivations we have discussed, that is area of a trapezium and area of a quadrilateral, and we have discussed one example for each. With this knowledge, I think you understand, and with this knowledge you can do some of the homework sums, that is from exercise number 11.2, question number 1, question number 2 and question number 4. So these are the 3 questions for your homework, and I hope you understood well and complete the given homework. Thank you very much.